In this final part of our little enemy series, let us go ahead and just finish up the logic. Let's have it so the player can kill the enemies by shooting at them, and the enemies can kill the player by running into them. Let us start off with the enemy killing the player. We have a lot of that stuff already set up. If you remember, when we hit the T key, we play our little death animation. We can't move anymore. Really, when the enemy hits us, that's what we want to do. So all of that stuff has been set up. We need a way for our enemy to communicate with our player and our player to communicate with our enemy. We currently have this BPI animation, but it's good to keep things organized. The name of this asset is BPI animation. Tells us that it should be controlling the animation somehow. It is a messaging channel for animation-based functions. So let's not use that for this. Instead, I'm going to make a new blueprint interface. And I'm just going to call this BPI combat. And this is going to represent a channel for combat-based functions. Let's open it up, and I'm just going to have one function in here called kill. This is going to be used both by the player and the enemy. And for now, we don't need any inputs or outputs. So what we want to do, in our twin stick pawn, we currently have this area where when we press T, we disable the input, play the death animation. We check if the player is dead. All I'm going to do is first implement our new interface, BPI combat. Compile it and use this, the new function here. So under interfaces, we have a kill function. Let's add that, pop it all the way up here. And let's replace this T with this. The only other thing I'm going to do is just reset the level when we die. So first I'm going to delay it, maybe delay it by 5 seconds. When that's done, let's get the current level's name. And we're just going to open level by name, and the current level is going to be the level that we opened. So we're just basically reopening the level, restarting the level. And we just need to trigger this somehow now. So let's do that when the enemy touches the player. So in the enemy, on begin overlap, on actor begin overlap. Let us first check if the other actor is the player that we're touching. So actor has tag. Let's make sure it's the player. And if it is the player, let us call the kill function. So we're calling the kill message, and the other actor is going to be our target. So before we try this, the capsule component is the one that's going to be doing the colliding with the player. So let's just see if everything is set up, if our collision settings are right with the capsule component. The capsule component can generate overlap events. That's correct. If I open up the collision presets, however, we can see object response is the pawn. Our player is a type pawn. It says block. We should just change that to overlap. So let's compile that and see if this works. There's my enemy. And they hit us. We die. Takes a second. Well, it takes 5 seconds. And our game resets. Cool. So that is our death working. I'm actually just going to make it a little bit nicer. And before the delay, I am just going to play sound. And I have added a death sound. Great. So now we have the kill function mostly working, as in the enemy killing the player. There is, however, one slight issue with this right now. Let's just take a look at that. Say we're shooting, and an enemy comes up and kills us.
I've never killed anyone who didn't partially deserve it.
So we could see there that I let go of the shooting key. Well, you couldn't see that, but I did let go of the shooting key, and my character was still shooting. So the problem here now is when we die, we disable the input. If we were already holding the left mouse button, this IA shoot would have triggered, and it's just going to keep playing this montage because we disable the input. It's never going to get completed. That release action is never going to, get triggered to help us trigger this complete. A very simple fix for this, I'm just going to make a custom function or custom event and call it stop shooting and just plug that into the stop montage. And when we die, we're just going to call this stop shooting function. That's just a very simple fix, but also, kind of an annoying issue to have. So let's just see this working now. So I'm going to keep shooting when the enemy runs after me.
I've never killed anyone who didn't partially deserve it.
And there you go. There was another problem that we saw there. We saw that the enemy didn't quite kill me, and I think the reason here was because the enemy's mesh was kind of hitting my player and blocking it, so it couldn't affect my player. So there's two solutions here. We could ignore the player in our enemy mesh, or we can make a new capsule collider and just make it slightly bigger than our character mesh. And this is just going to be the collider that kills the player. So set the half height to the same, make it just a little bit bigger, and make sure that it overlaps with the pawn. So now we shouldn't have those issues.
I've never killed anyone who didn't partially deserve it.
Okay, perfect. So we've got the enemy killing the player, and we've tweaked a few small issues that we might be having. Now let's get the player to kill the enemy. Again, we have a lot of this done in this event down here, event shoot. We have basically done everything, and when this print string is true and we say enemy hit, this is where we want to call kill on the enemy. Let's do that. Let's go back to our enemy and let's implement this function now. So under, I'm not sure where it is. I see the issue. We have not implemented BPI combat in the enemy for some reason, although we should have to be able to call this. Either way, just implement the interface and let's create a kill function. So let's deal with this kill function in a kind of fun way. Let's have the mesh ragdoll, because ragdolls are cool, and I like ragdolls. Just a quick note, our ragdolls aren't going to be very good. They're just going to be the default ragdolls, and that's okay for this. Ragdolls require a fair amount of tweaking with their collisions and their bone rotation limits and stuff. So I wouldn't worry about that stuff too much, but even just having a ragdoll crumble, if it's not completely wigging out, it looks cool. So let's do that. So when we kill the enemy, we first want to disable their movement so they're not moving anymore. We then want to take their mesh, and we need to set simulate physics to true. And we also need to get these two box collider, or these two capsule colliders we have, and we need to turn their collision off. So I'm going to go set collision enabled, no collision. And finally, let's add a delay of maybe around a second, and then just destroy the actor so that, we see them ragdoll, they hit the ground, and then we destroy them. So we just need to call this function, this kill function. Actually, we already did that here. So when we hit the enemy now, it should go into this kill, which should kill the enemy. So let's see if this worked. And it worked. They did go falling through the floor, but we can fix that. I think just instead of this capsule component having its physics set to no physics, let us just change it to physics only, no query collision. And let's see if that worked just fine. And no, they still fall through the floor. All right, let's go see what's wrong here. Okay, that simple was fixed enough. Or I'm sorry, that fix was simple enough. All that happened was in our BP player, the self player, we just need to make sure that the object response for world static and dynamic, which are basically all these actors that we place in the world, this mobility is either static or movable. So static is static, movable makes them dynamic. We just want to set those two layers to be blocks. So they were set to ignore for some reason. We're going to just make sure that they're block. And now when we kill the player, they ragdoll. Let me make that timer a little longer so we can see the ragdoll happen. In BP enemy, let's just make it, I don't know, 4 seconds. So you'll see the ragdoll working, but you'll see their arm kind of wigs out, and that's because the ragdoll settings weren't set correctly. We're not going to work on fixing them. Ragdolls require a lot of tweaking. I just want to show you where these settings are. In our enemy, when I imported the enemy, one of the items it gave us was a physics asset. And this is the asset that's used when our player dies. You can see that there are bones here. They're not even a lot of bones. We have more bones in our skeleton than we do in our physics asset, because all these bones, quote unquote, really are colliders. You can see these little capsules here. Each one represents a collision box. Each one also has a limit of movement. So when we click on one of these colliders, we can see there are a boatload of options on the side here, and really that is how we are going to we're going to modify these collision boxes. You can see right now that you can see the axes that can move on. That's what's represented by these little colors. So they can rotate on the Y and the X axes, and they can rotate at a full limit. Really, part of the thing of setting a ragdoll is in these linear and angular limits. Make sure we limit the swing. You can see how this rotates. You can see it being affected on the screen. And so a lot of tweaking is required. You want to set the limits of how much each bone can rotate. For example, your wrist can rotate a certain amount, your elbows can rotate a certain amount, your shoulders can rotate a certain amount. And making a good ragdoll is really setting all of that, making sure everything is dampened just a little bit so things don't move super fast. I'm not going to bother with that. That is a lot of tweaking. It's very fun to do. Getting good ragdolls in a game really does make it feel visceral. But for our purposes, I think this is fine. Okay, so now we have our enemies working and our players working. When we shoot our enemies, they die. Let's just make our enemies a slight bit more interesting on death. Rather than them just crumbling to the ground, let's add a small force to them so we can push them when they die. So they go falling backwards when this happens. To do that, we are going to use a function called add impulse. This is added on to the physics. So if I take the mesh out, I can call add impulse. And here we can give it an impulse. An impulse is just like a push. I'm going to make sure velocity change is checked. And I want to call this before we actually run the delay. Now, we need to figure out where we want to add this impulse and what direction. So to do that, I'm going to go back to my BPI combat. I'm going to add an input, and I'm going to call it hit location. So depending on where we hit the player, we want to be able to run this impulse function in that direction. Or really, I shouldn't call it hit location. I should call it hit normal. So we're going to get the normal, the face normal from where we hit it. We're going to just send them flying in the opposite direction. Okay, so now when we call this hit function, I can pass the impact normal along here. And then in our BPI enemy, all we need to do is first, before we work with any vectors, let's normalize it. And then let's flip the vector around by multiplying it with -1. And then finally, let's multiply it with some random scale factor in order to make the impulse, feel more strong. And I think to do that, let's use a random float in range, which gives us a minimum maximum. And this is going to require a lot of tweaking, just like trying it out and seeing what works and what doesn't. But I'll give it a fairly large range, 5,000 to 9,000, let's just say. And we just plug that in here. See if that worked just fine. And you can see they went flying. Maybe 5,000 or 9,000 was a little too much. You could reduce that. But, adding that little impulse made the enemy's death feel a little more nicer. It gave our player a little more feedback, a little more viscerality to the gameplay. Okay, let's work on the last bit of this. We now have a complete working game in a sense of, or we have a complete working combat system. Our player can die. The game will restart when our player dies. And we can shoot the enemies, and the enemies will die if our bullet hits them. So we have kind of our enemies are designed to, overwhelm the player probably in numbers or speed. And really the game design can change how you want it to. But that's a kind of enemy we've designed here. Let us do one last thing. Instead of having to place every single enemy, by hand, which you can do if you want, I'm just going to make a simple enemy spawning class because I would rather just make define a small area and have the enemy spawn in that area. So let's do that. I'm going to first go back to my content, and I'll just put this in the enemy folder. I'm going to make a new blueprint class of type actor and call it BP enemy spawner. All this class is going to have is a simple box collision. And I want to be able to edit this box collision in the level so that my level designers can decide where the spawner is and how big they want it to be. So to do that, I'm going to drive this box extent thing, which controls how big the box is. I'm going to drive that with a variable. So we'll call it box extent. I'm going to make sure that it's a vector. And always make sure that it's instance editable and that it's public. Then in the construction script, I will just call set box extent. Make sure I set the box extent to this new variable that I made. And also, I will make sure to show the 3D widget so that we can edit it conveniently in the editor. All right, so now when we add this in, we can see it's a tiny box, but we have this little box extent. And when we drag that, we can see our box growing. So for now, let's just set it up here. Make it a little smaller. Okay, so that's our box extent. Oh my. And we can edit the size. Convenient. Let's get the actual spawning going. This is also fairly simple. We are going to use, we'll make a custom event for it and call it spawn enemy. And all it's going to do, fairly simple, is spawn actor. Spawn actor from class. Oh my. Spawn actor from class. There you go. And we are going to spawn BPI, just BP enemy. We need to give this a transform somewhere to spawn. It's not going to let us compile without that. And if we just use this actor's location as a spawn point, it'll just keep, well, it says bad blueprint because it's not compiling. But if we did just use the actor location as a spawn point, it's just going to, every enemy is just going to spawn in the middle of the spawn point. But I have this big box collision, so I actually want to just select a random spot somewhere in that box collision's volume and spawn them there. We have a function called random point in bounding box. And for the center, we can use the actor location. And for the half size, we can call get scaled box extent. Since my box is technically 111, get unscaled will work fine. If you do actually scale your box, I'm using the box extent number, but if you use the scale number, then you would call get scaled. Either way, both are the same in my case. So I'm just going to use this. And we will make a transform out of it. We can leave the rotation as 0, 0, 0, and the scale is 1, 1, 1. That's just going to be default. This will let us compile it. And now we just need to call this function. So to do that, I'm going to use a timer. So on begin play, I'm going to set a timer by function name. What is that function name? It's spawn enemy. We're going to make sure it's looping. And instead of just giving the timer a time, let's do random float in range again. And we will do it between, 5 and 10 seconds. Again, this is all subject to a lot of tweaking to how you want your specific game to feel. Now, let's just test it. Let's hit play. I'm just going to jump out of my player. And let's see if it worked. There you go. There's an enemy. Maybe 5 to 10 seconds was too long. Let's, for now, just do it between 1 and 2 seconds. So we spawn a lot of enemies. I'm just going to hit simulate. And there you go. We have a bunch of enemies spawned. There is an issue right now. They are not moving for some reason. So let's go see what's wrong there. Okay, let's take a look at that issue again real quick. So what was happening here, which is actually not happening right now, but I'll show you the fix anyway, is that when we had spawned our AI, they weren't moving. And the reason for that was back in our enemy blueprint class. BP enemy. If we click on enemy self and we search for possess, currently auto possess AI by default it's just placed in world, which is what we were doing. We were dragging them in. The other option is spawned, which is what we are doing now with the spawn actor from class. So it was just set to place in world, which when it was set to that and we played it, because we were spawning them through this actor, the AI wasn't possessing them. So really we just want to do both, place in world or spawn. And that was a simple fix. Again, Unreal, it's just a checkbox away from being fixed. And there you go, that works just fine. So our enemies now spawn in. We can add multiple spawners through our level if we choose to make an endless horde game. We can even drive these timer values through variables, for example, and we can increase or reduce the timer. So we can reduce the minimum and reduce the maximum time so the enemies spawn faster as the game goes along to make it harder. There's a lot that we can do from here. We have set up a very basic game with functionality. If you guys think back to our first few weeks, you can implement a health system, a scoring system, just really make this game fleshed and complete. I'm sure your imagination can take you to many places, obviously adding music, adding more particles if you find them, like a blood splat when our player shoots the enemies. But there's, again, a lot of ways to improve from here. We have done the basics, but we have managed to create a twin stick class from scratch. Obviously, we're using Unreal's character component to, drive everything. But we've created our player. We've learned about animations doing all this. We've learned about the basics of AI. Unreal has a lot to offer, and we've just kind of broadly touched over some of the blueprinting capabilities that Unreal has. So I hope to see your guys' Project 2 incorporate all of this and everything we have done in Project 1. I'm excited to see everything. Thank you guys for watching.